Hello there. Good evening. Good evening. Okay, what I want to do this evening is to continue looking at in respect of transformers. Okay. Okay. In respect of transformers. So I'm just having a little fondle here with this thing. It never seems to do what I want it to do. 1 second. Okay. So what I want to look at is transformers, and in regards to this session, you're going to look at Transformers 2. It'll be session 10, Transformers 2. Okay. Aim and objectives of this session is to understand the construction of a simple transformer to be able to state how voltages are changed. Okay. And that's something that we will be doing this evening. Now, again, remember to look for additional information. Make sure that you are looking at and studying the IEE regulations. Okay. There may be changes in that which you need to make yourself aware of, but don't hesitate to go and find out. Okay. Right. Let me get to work now. Okay, let's see what we got. One year. Nope. Good. Good. Okay. Now, one of the things I'm trying to get here is to get a certain amount of work done so that you guys can continue to learn through the whole academic year, if possible, if you choose to. But I know some people like to go away for a few weeks because winter dictates that we should have a reasonable break. Okay, let me just get this in. Okay. Okay, let me just get it. Okay. And okay, good. No, that was easier than I expected. Goodness me. Okay. All right, session 10, transformers. To understand the construction of a simple transformer, be able to state how voltages are changed. Okay. Now again here, this is what we've done previously. So you need to look back at some of the videos on my channel to make sure that you are familiar and you have the relevant knowledge and information that you need. Now, transformers. A transformer is a device that converts alternating voltage at one level to an alternating voltage at a higher or lower level. And here we have a diagram of a laminated sheet that goes to make up a transformer. Okay, and this is just a simple diagram. Here, this is a step-down transformer. We know that because there are more windings on the primary and there is on the secondary. Okay. The above diagram shows a simple double wound transformer. The coil on the left is called the primary, and the coil on or winding on the right is called the secondary. Okay. Now, double wound transformer. Now, a double wound transformer is actually a coil wrapped around a coil, and the inner coil will form your primary windings, and the outer coil will form your secondary windings. And this is done by the primary coil create an induction of magnetic flux into the secondary coil, causing that to create a transformer system. Now it is quite proficient actually, and when you look at the diagram, you see that it is a coil wrapped around a coil, and basically it relies upon the interchange of the magnetic flux. Most double wound transformers look slightly different in that the two windings, primary and secondary, will be on the same leg of the core. This helps reduce losses, okay? Then remember the core, your main structure transformer will be laminated and held together. The idea here is to make sure that you reduce eddy currents and reduce the heating effect wherever possible. Now, three-phase transformers. And here we have three-phase transformers. And here we have brown phases, black phases, gray phases, okay? And one is called your shell type transformer, and one is the core type transformer. In a three-phase transformer, the transformer is slightly different. There are a series of three windings on the primary and secondary. The windings on a transformer are sandwiched or wound on top of each other to help the distribution of magnetic flux. Okay. Now you will need to look at this. Now you cannot see what I am looking at, so you will need to look at the video itself to see how this links in. Okay. Three-phase supply. Okay. In a three-phase supply, there are effectively three supplies all rising and falling at the same time. Okay. Brown, black, gray, and here's your sinusoidal waveform of your three-phase supply. Okay, the secondary windings can differentiate between varying magnetic fields because each produces a particular phase, and these are at a maximum and minimum at different times. And don't forget, they're 120 degrees out of phase, okay, with each other. Now here we have an auto transformer, very interesting auto transformer. You have one coil, one core, soft iron core, and you have around that soft iron core, you have coils of cable wrapped around. And you have your input at one end, and you have your positive input at one end and negative input, of course, at the other end. But it all goes through that coil. And to take your voltages off, you simply tap at a given point along the iron core to tap your voltage is off, and that will give you your voltage. So you can have a variation of voltages coming from your auto transformer, like you would have in your, these transformers we have that gives you 4.6 volts, 5 volts, 6 volts, so forth. That is what you can have in effect with your auto transformer. Okay. An auto transformer differs from a normal transformer because there is only one winding. To get different voltages, there is no reduction of turns on the secondary, but there is a direct connection to the coil. So you simply tap off the voltage from the coil that you want at that point in time. Okay? An advantage of this, you can reduce the overall size of the transformer. Disadvantages are that under fault conditions, a supply voltage can appear across the secondary, which means this transformer cannot be used for isolation purposes. Instrument transformers, okay? In large power circuits, it is not possible to measure either current or voltage directly. This is because the meter used would have to be very large for the levels of voltage and current. When measuring instruments placed in circuits, it is not appropriate because of the large voltage and current. Then voltage transformers and current transformers are used. And here we are with the voltage transformer, VT. The voltage transformer's primary side is rated at the supply voltage. The secondary side is rated at 110 volts. This is a step-down transformer, okay? So the output here will be 110 volts. Now, current transformer, CT. Now, the primary windings you have here, okay? Secondary winding, current transformer itself has coils wrapped around a core, okay? And you can see your amp meter being connected here. This type of transformer uses the supply conductor as the primary winding. The current transformer takes the magnetic field from the conductor. The CT is a step-up transformer. The ammeter is connected across the secondary of the transformer. The normal rating of the secondary is approximately 5 amps. And here we have current transformer, okay? Now, this diagram shows how the CT would be connected into a circuit. Yes. The switch across the secondary is for protection and isolation of the ammeter. However, this is not recommended in the EWR 89 regulations. Electricity at Work Regulation 89 regulation. Now, please check this regulation again, 89, in case it has been modified or changed. Okay? So don't take this as read. Okay? These regulations are open to modifications and updating at given point in time. So make sure that this is still relevant as it stands. So the supply is usually switched off or isolated before working on an instrument. Air-cooled transformers. Interesting. The simplest kind of cooling available is air, called air is free. Okay, there are two types of air cooling. These are natural air and forced air. The air-cooled transformer will be labeled with one AN or the other AF, or possibly both. It is important to check for damage before installing the transformer. This type of transformer must be installed indoors and surrounded by an earthed metal case or enclosure. If the transformer has been stood for some time, it is necessary to carry out an insulation resistance test. Don't just go out and connect it up back or put the load onto it. You need to make sure that it is safe to use at all times. And that is your job. Check, 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 and check again. Okay? Oil-cooled transformer. Now, with oil-cooled transformers, we have to consider the cooling of the transformer and the cooling of the oil itself. The labeling on oil-cooled transformers has 4 letters, possibly ONAN or oil natural A natural. The The first two letters describe the removal of the heat from the transformer. And the second two denote the removal of the heat from the oil. When installing oil-cooled transformers, there needs to be a means of containing the oil and a means of containing the oil should it leak. Okay. And what I've done here, I'm hoping that I can see it. Can I see it? Am I still? One second. Let me see if I've got what I have in mind. 1 second. You have seen me. Go to here. Okay. Yes, I've looked at some of these and tried to ensure that we give it an idea of to the real world usage of these things. Okay. Feel free to do your own research as well in addition to this. Okay. Okay. So forth. Now remember that heat rises, so as you create a system, you will create veins on the transformer, which the oil passes through and is cooled, and the heat goes to the air. It would be very interesting actually if we can actually capture that heat some way and use it. Again, with all this environmentally friendly approach in regards to the environment. Okay. Okay, I hope you found this useful. And you can look at this on the web. Okay. But that will be it from me for now. Thank you. Okay. Have a good day. Bye-bye. What happened there? Oh, that was easier than I expected. One winding. To get the... Okay, hang on. No, that was easier than that. All cool transformer. Now, okay, I hope you found this useful. Okay, thank you. Okay, good. It's okay. I'm just checking to see that I got it in place. Sorry about that. Let me just get back to you. Okay. All right. Thank you. Have a good day. Bye-bye.